Building bridges over deep water. How engineers anchor pillars in rivers and seas. Hello, friends! Whenever you see a bridge stretching over a mighty river or a vast sea, a question must surely cross your mind. How on earth do engineers build those massive pillars in such deep, flowing water? And how does the concrete even set amidst all that water? It seems like an impossible task, especially when you consider that these structures must bear the immense weight of vehicles and withstand the forces of nature without toppling over. If you've ever been curious about the secrets behind constructing bridges over flowing water, you're in the right place. Let's dive deep into the incredible engineering methods that make it all possible. The core challenge, the foundation. The most difficult part of building a bridge isn't the visible roadway. It's creating a stable foundation and the supporting piers beneath the water. With water flowing all around, how do workers pour concrete or drive piles? Engineers have developed several brilliant techniques to tackle this, primarily by creating a temporary dry workspace right in the middle of the water body. Method 1. The Cofferdam, creating a temporary dry island. For bridges in rivers or relatively shallow waters, one of the most common methods is using think of it as a massive, watertight bathtub. What is it? A cofferdam is a temporary, leak-proof structure made by driving a wall of interconnected steel sheets called sheet piles into the riverbed, forming a large enclosure. If you've seen a construction site on land supported by metal walls, that's essentially a smaller version of the same principle. How it works. Installation based on the water's depth and the riverbed's soil conditions. Huge steel sheet piles are transported on barge using a giant crane and a vibrating or hydraulic hammer. These sheets are interlocked and driven deep into the riverbed at the precise location where a pillar is needed, creating dry space. Once the cofferdam's walls are sealed into the bed, powerful pumps work continuously to remove all the water from inside the enclosure. What remains is a dry, exposed patch of the riverbed, now isolated from the surrounding water. Construction in the dry. With a solid, dry work area, construction crews can now work just as they would on land. They excavate further if needed, build reinforcing steel cages, and pour high-strength concrete to form the bridge's pillar and its deep foundation. This allows for precise, high-quality construction removal. Once the concrete pillar has cured and gained full strength, the cofferdam's purpose is served. The water is allowed back in, the sheet piles are extracted, and the temporary structure is moved to the next pillar location. The permanent pillar stands firm, now surrounded by water, but built in perfect conditions. Method 2. The Caisson or pile foundation for deep and treacherous waters. But what about deep-sea bridges, where the water is too deep for a cofferdam to be practical or safe? Here engineers turn to a more robust technique, board pile or Caisson foundations. What is it? This method involves using giant, hollow steel pipes that act as both a mold and a structural core. These pipes can be several meters in diameter and are engineered to reach incredible depths, sometimes hundreds of meters below the seabed. How it works. Lowering the giant pipe. Enormous steel casings pipes are fabricated on shore, transported vertically by specialized barges, and carefully lowered to the bridge site. Using a combination of cranes and underwater guides, the pipe is positioned perfectly. Driving it home. A massive hydraulic hammer, often mounted on a floating rig, drives the pipe vertically through the water and deep into the seabed. This requires immense precision to ensure the pile is perfectly aligned. Excavation and concreting. Once the pipe is securely embedded, an underwater excavation tool removes the soil and water from inside it. Then, the hollow pipe is filled with reinforced concrete, creating a monolithic, incredibly strong column that is rooted deep into the stable layers of the earth below the seafloor. An unshakable base. This method creates a foundation that is virtually unbreakable. Once set, this concrete-filled steel caisson can withstand tsunamis, powerful currents, and the relentless pounding of ocean waves. It becomes an immovable anchor point for the bridge above, from pillars to pathway, building the superstructure. Once the piers are firmly rooted in their robust foundations, the next phase begins. Constructing the bridge, deck the part. We actually drive on precast segment construction. Modern bridges often use a method where giant concrete segments are cast on land in a controlled factory environment. These segments are then transported by barge to the bridge site. The assembly, using a giant launching girder or crane, These precast blocks are hoisted into place atop the pillars. They are meticulously aligned and then permanently joined together, using high-strength steel, cables, post-tensioning, and concrete. This is like assembling a giant, incredibly strong Lego set in the sky. Finishing touches. Once all segments are connected, the final roadways surfaced, safety barriers, lighting, and other utilities are installed, completing the bridge. Conclusion: a triumph of human ingenuity. So, the next time you cross a bridge, take a moment to appreciate the marvel beneath you. What looks like simple pillars rising from water is the result of profound engineering ingenuity. From creating temporary dry chambers in raging rivers to hammering colossal piles into the dark ocean floor, these techniques allow us to conquer geographical challenges, connect communities, and build pathways that defy the very elements they stand upon. These awe-inspiring bridges don't just cross water. They symbolize humanity's relentless drive to innovate, connect, and progress. If this exploration of engineering resonated with you, please like, subscribe, and share your thoughts in the comments below. Your engagement encourages the creation of more content like this. Thank you for reading. Until next time.